Hi, everybody. Welcome back to the Feynman Technique. So today we're going to be deriving this relationship between the beta and gamma functions. Now, I haven't really talked about the beta function much on this channel. It's just an integral defined in terms of x and y. First, let's talk about what the gamma function is. This is the gamma function. We've derived its result on this channel before. So we'll be using this. This is just the gamma function, and this here is the beta function from our original formula here. That is beta of xy. So beta of xy is defined like this, and gamma is defined like that. All right, so we are going to show that this is equal to this. All right, so to start, what we're going to do is we're going to let w equal tu in our gamma function definition. That means dw is t du, and if we plug that back in, now we have a different version of our gamma of x. So gamma of x is now equal to this. All right. Well, if we expand the exponential terms, we get this. All right, so now gamma of x is now equal to this. All right, and we bring out we combine the exponentials and bring out the things that don't depend on u. So now we have this. All right. Well, now let's strategically multiply both sides of our equation, right? We have this equation right here. Now let's multiply both sides by e to the negative t times t to the y minus 1 power, giving us this. Now this might seem a little confusing, but this is very carefully chosen, and um, I'll let you guys figure out, maybe try to figure out why we did this before we continue. So think about why we might have done that before we continue. So we multiply both sides by e to the negative t times t to the y minus 1. All right, what are we going to do next? Next, we integrate both sides from 0 to infinity dt. Okay, so all we literally did is took this and then just put an integral sign from 0 to infinity dt on both sides. All right. Um, so now you'll notice that this gamma of x and this t to the y minus 1, or I'm sorry, this gamma of x is completely independent of that. And we can use Fubini's theorem over here after we combine some stuff. So let's do that. You'll notice that after we factor out that gamma of x in this integral, all that's left is gamma of y. This is our gamma function of y. And then we have this still on the right-hand side. All right. And now we can use Fubini's theorem on the right-hand side um, to swap the order of integration. So we're going to integrate with respect to t first and then with respect to u. And there's no problems with convergence either way, so we can do that. All right, and now we're going to combine factors and things like that and then bring out all the things that don't depend on t inside our inner integral. So we factor out that u to the x minus 1, and now we have this inner integral right here. And now in our inner integral, we are going to let s, some new variable s, equal t times 1 plus u. And you can see that is right here. So this is going to become our new variable s after the substitution. All right. Well, doing all the differentiation in algebra is going to give us that dt is ds over 1 plus u. So plugging all that stuff back in, and now we just have this integral. All right, and the bounds of integration remain unchanged. Okay, so you'll notice there's going to be a lot of stuff. Well, there's going to be some stuff that happens here. Let's see what happens in the next step. All the stuff that doesn't depend on s comes right outside the integral, and we're left with just this inside the integral. All right. And now you'll notice this just becomes 1 over 1 plus u to the x plus y times, let's see, what is this really? This is gamma of x plus y. So that whole right-hand side just becomes 1 over u, 1 plus u to the x plus y times gamma of x plus y. So now we are left with just this. And you'll notice that this is constant with respect to u. So we can bring that right outside the integral. So now we have gamma x times gamma y is equal to gamma x plus y times this. And what's this? Well, let's let u equal v over 1 minus v. Doing the differentiation in the algebra gives us that dv or du is equal to 1 over 1 minus v all squared dv. Our bounds are going to change if we let u equal 0. In our substitution, that means v is 0. If we let u equal infinity, then we get v is equal to 1. All right. So now that side just becomes gamma x plus y times this integral, and there's a lot of simplification that happens here. We get this. And then finally, we get this. And what is this? This is the beta function. This is beta of xy, exactly. So now we have gamma xy is equal to gamma of x plus y times beta of x comma y. Dividing both sides by gamma of x plus y gives us our famous relationship, and we are done. All right, guys, hope you enjoyed that, and we'll see you next time.